Imagine waking up tomorrow morning. Your Wi-Fi connects just fine, your phone shows a full healthy signal, but absolutely nothing online works. Google doesn't load, your messages refuse to send, your banking apps just time out. Streaming is totally dead, and it's like your favorite websites have just vanished into thin air. Welcome to today's Explainer. We're going to dive into the massive, wildly complex infrastructure sitting right beneath our screens to answer one really big question. What does the internet is down actually mean?
Right, so it's the ultimate modern nightmare, isn't it? What if the internet just stopped? To really wrap our heads around this, we have to challenge a super common assumption. A lot of us tend to think of the internet as this giant utility, kind of like a water pipe or the electrical grid. We imagine there's some master switch out there that you can just flip on or off. Okay, let's dive into this. When you experience that heart-stopping moment where your Wi-Fi says it's connected, but your banking apps are failing, your messages are unsent, and websites are just gone, you aren't actually experiencing a global shutdown. What you're experiencing is a highly localized illusion. And here is exactly why. The internet is a global system of interconnected networks. It is not a single centralized machine. Literally, there is no off button anywhere. The internet is actually this massive, sprawling collection of independent networks. We're talking universities, private companies, telecom providers, and they're all just agreeing to talk to each other. It's millions of separate pieces continuously shaking hands. So let's move into section 1, breaking the connections. Let's say you type a domain, like ican.org, into your browser. Your computer doesn't naturally know where that is in the world. It relies on the domain name system, or DNS, basically the internet's phone book. It's this rapid-fire, 5-step lookup process. Your browser asks a resolver, which then queries a root server, which points it to the .org top-level domain, which then checks the authoritative DNS, and finally returns the exact numerical IP address so you can connect. And all of this happens in just milliseconds. Now, the difference between a DNS failure and a true loss of network connectivity is absolutely fascinating. If that DNS phone book breaks, your computer suddenly has no idea how to translate names into numbers. So websites appear completely broken, and it really feels like the internet is down. But in reality, the underlying network connections are working perfectly fine. You didn't lose the road, you just lost the map. Or let's take your internet service provider, your ISP. If your ISP goes dark, your entire house loses its connection. And yeah, it feels catastrophic, but we have to clarify something important. An ISP outage is just a local or regional connectivity problem. Your specific neighborhood went dark, sure, but the rest of the world is humming along without even noticing. But how does all that data actually find its way across the globe? It uses BGP, the Border Gateway Protocol. Thousands of independent networks use this to exchange routing information and find the absolute best paths for your data. Now, what's really interesting about this is how it allows traffic to bypass failures. If a network pathway goes down, BGP dynamically reroutes and just finds a new way around the blockage. However, that rerouting isn't always instantaneous, and it's definitely not always perfect. When a route disappears, traffic frantically tries to find another path. These routing failures can cause unreachable websites, regional access loss, and heavily rerouted traffic. And all that rerouting, it often leads to increased latency, which is really just the technical way of saying your connection becomes unbearably slow. Let's dig a little deeper into Section 2, severing physical infrastructure. I want you to think about this incredible quote from CFR Education for a second. Nearly 99% of all our data is transmitted via submarine cables using fiber optic technology. That means everything from your highly secure banking data to those cute puppy videos on your feed travels along the ocean floor. And this brilliantly illustrates that the cloud isn't up in the sky. It's mostly sitting right at the bottom of the ocean. Which brings us to this absolutely staggering number, 750,000. That is the number of miles spanned by more than 400 submarine cables wrapping all the way around the globe. So if a ship's anchor accidentally drags across one of them, or an underwater earthquake severs a line, massive amounts of data suddenly have to find a totally new way home. You see, the internet isn't some magical thing floating in the ether. It is extremely tangible. Submarine cables, miles of underground fiber optic lines, massive routers, sprawling data centers, cellular towers, internet exchange points. This is heavy, physical infrastructure spread across the entire planet. And remarkably, it's largely owned and maintained by private companies. And this physical reality makes a huge difference when things break. We really have to contrast a cloud outage with an internet outage. Look, if a massive data center belonging to a major cloud provider catches fire, thousands of specific apps are going to crash. But the underlying internet itself, it continues to function completely normally. You just can't reach the apps that were hosted in that specific burning building.
Which leads us to Section 3, the real-world impact.
The tangible inconveniences of a layered failure hit you immediately. Imagine you're standing in a coffee shop. Your digital payments fail because the shop's ISP is down and they can't reach the bank. Your favorite social media becomes unreachable because their specific data center is having a routing issue. Your text messages just sit there queuing locally on your phone, refusing to send. It feels like a digital apocalypse, but the broader internet itself is actually perfectly fine. Navigation is such a perfect example of this disconnect. GPS satellites transmit their positioning signals completely independently of the internet. Your phone's internal chip can calculate its exact coordinates without a single drop of Wi-Fi. But your phone's map application? Well, that still needs internet connectivity to download the visual streets, the names of the restaurants, and the live traffic data. Without the internet, you just have a lonely blue dot floating in a big empty void. And speaking of satellites, to put things into perspective, did you know there are over 12,000 of them operating in space right now? They provide things like GPS and remote connectivity, particularly out in rural areas, and they all operate under international frameworks like the 1967 Outer Space Treaty. So even if massive terrestrial cables fail on the ground, we literally have infrastructure orbiting the Earth to help keep the data flowing. Back down on Earth, networks physically plug into each other at massive buildings called Internet Exchange Points, or IXPs. Now, if a major physical exchange point goes dark, say due to a power grid failure, it impacts only the networks and routes relying on that specific physical location. Because of modern load balancing and redundancy, the rest of the network will dynamically attempt to redirect traffic right around the dead zone.
All right, Section 4. Can it all go down?
It's the big one, right? Could a single catastrophic event actually destroy the entire internet? Could we wake up to a world that is permanently disconnected? Well, before you start hoarding canned goods and building a bunker, prepare to be completely reassured by the system's incredible foundational design. So, the cruciate point is right here. The distributed nature of the internet provides massive redundancy across multiple routes, providers, and physical connections. Because there is no center, a truly global failure would require an extraordinarily widespread disruption. We're talking thousands of independent systems, satellites, servers, and cables all having to fail at the exact same time. And that brings us to our absolute core takeaway for this explainer. The internet doesn't fail like a light switch. The internet fails in layers. An outage could be your home router acting up. It could be your local ISP. It could be the DNS phone book going offline. It could even be a severed submarine cable. But it is almost never the entire system. So I want to leave you with this final thought. The next time a website doesn't load or your messages just refuse to send, don't panic about the whole system collapsing. Instead, ask yourself, what specific layer of the network just failed? Thank you so much for joining me for this explainer, and keep exploring the amazing layered world right beneath your fingertips.